Good morning, children. Today we are going to discuss about the various types of graphical representations of numerical data. You have already done two of them in your junior classes, that is a bar graph and a histogram. They look quite similar to each other and sometimes we get confused. So let us quickly discuss what is the basic difference between a bar graph and histogram. Though they look quite similar to each other, but there are two basic differences between these two types of graphs. Number one, for bar graph we use discrete frequency distribution table, whereas we use continuous table for the histogram. The second basic difference between these two graphs is that there are spaces between the bars in a bar graph, whereas no spaces are there between the bars in the histogram. The main reason for this is that in a discrete frequency, we are not taking every possible value. For example, if we have a discrete table and the first value is 2 and the second value is 7, we are not taking any values between 2 and 7. Whereas in histogram, if I am taking a class interval 2 to 7, then every possible value which is lying between 2 and 7 will lie in this particular interval. So that is why it's a continuous interval. We are not leaving any values. So there are no spaces between the bars of the histogram. You have already learned how to make the histogram when all the class sizes are same. Today we are going to learn how to make a histogram when the class sizes are not same. So let us consider this example. In this example, you can easily see that the class sizes are not same. For this type of situation, we are going to make a table containing 4 columns. We are going to add 2 columns here, that is class size and adjusted frequency. So we will find the class size of each interval, and after finding the class size, we will take the smallest class size here, which is 4 in this case. Now to find out the adjusted frequency of various classes, we will divide the smallest class size by the class size of that interval and multiply it by the frequency. So the adjusted frequency of the first interval is 5. In the same way, if I take this interval with class size 20, so smallest class size divided by the class size of that interval into its frequency, it will give us adjusted frequency 5. In this manner, when we find the adjusted frequencies of various classes, we get this table. So now we will not use the given frequencies, but we will use these frequencies to plot the graph. And this is what we get on plotting these new frequencies. You can observe that the class sizes were not same, and that is why the width of the bars is also not same. The next type of graphical representation is called frequency polygon. The frequency polygon can be drawn in two ways. One is with histogram and other is without histogram. So let us take these two methods one by one. First one is when we are going to draw this with the histogram. It's quite easy because you have already drawn the histogram. To make the frequency polygon in this case, we have to mark the midpoints of the upper line segments of each bar, and along with this we will also mark the midpoint of one previous interval and one interval after the given intervals. Now we'll join these points one by one in proper order using the scale, and this is what we get. So you can see the frequency polygon here. Why is it called a frequency polygon is because it's a polygon. You know that a polygon is a plain closed figure made up of line segments. So you can see it's a polygon whose one side is this axis and the other sides are the dotted line segments which you can see in this figure. Now, if you are asked to make a frequency polygon without histogram, in this case, we have to first do some calculations. Let us consider this example. We are going to make three columns in this table. First is class interval, second is class marks, and third is frequency. You all know how to find out the class marks. The class marks are obtained by adding the two limits and dividing by 2. So minus 9 plus 0 is minus 9 and minus 9 divided by 2 is minus 4.5. Same way 1 plus 10 is 11 and 11 divided by 2 is 5.5. So on solving it we get this table. Now in this table we are going to plot class marks with the frequency. Class mark will be plotted on the x-axis and frequency will be plotted on the y-axis. On plotting the various points on the graph and joining them in proper order, this is what we get. So it's a frequency polygon.